we have already discussed the basic point that product is Markovnikov, but without rearrangement, right? This is without rearrangement. So we can take any substrate like this, right? And what are the reagents? In the first step, we have to use Hg, OAC, mercury acetate, and water. And in the second step, demercuration step, NaBH4 in alkaline medium, right? So what should be the product in this case? The product is anti-Markovnikov and without rearrangement. And addition of water will take place. This OH2, this is coming here, right? So this bond is formed and this bond is formed. Which bond is cleaved here? This bond is cleaved, right? So what is the stereochemistry of this? This is anti-addition. Anti-addition. राइट इस तरीके का सिस्टम दिया जाता है और आपसे प्रोडक्ट पूछा जाता है इसमें और H2O and NaBH4 so what should be the product? The product is anti-Markovnikov or Markovnikov? Markovnikov. So OH will attach at more substituted carbon at this carbon and H will attack here, right? Finally. So we will get the final product. This is the reactant we have. Now, first step form, and this is a tertiary butyl group. So what this group will do, this will lock the flipping of chair form, right? So suppose that we have drawn the chair form like this. So this tertiary butyl group, this will lock this flipping of this, chair form or chair conformation, right? This HgOAC, this will form the transition state, three-member transition state. How you can see this double bond HgOAC, one OAC group substituted, and here positive charge will come, right? Now in the second step, now water is there in the same step, so water will attack either from this side or from this side. So water has two choices for attack here, right? So in the next step, once water will attack this side, so water will come here, OH will come here, this side, because this will attack water, right? And the ring is locked. There is no possibility of the flipping of this ring. And right now, if you take second step, this is the first step. After that, in the second step, NaBH4 and NaOH or just alkaline medium you can take. So what we will get in this, the change is here, OH This is the final addition. Right. So what is the, stereochemistry of this product? If you consider this group and this group, are they cis or trans? This is cis or trans? Anyone? With respect to this tertiary butyl group. What? So these two axial equatorial 1,3, 1,3 axial equatorial. This is trans, right? So this is trans. So which product we are expecting here? Trans should be the major product, but cis slightly more. This is 54% and this is 46%, right? Pasto, DJ et al. You can check the reference for this reaction. ACS 1971, page number volume 93 and page number 6902 to 6908. So you can check the this reaction in this reference. So this is the stereochemistry of this oxymercuration, demercuration, right? Now, if we take similar compound, like this, suppose that this trans. So this is all about oxymercuration and demercuration. Now I am taking next reaction of electrophilic addition, that is addition over conjugated system. So suppose that we have butadiene like this, and if we take one equivalent of HBr, right? So now we have two possibilities here, that this double bond have this 1,2 product, means HBr, H attack here, Br will be here. So this is called 1,2 product. And one more product is possible here, that H will attack here and Br will attack here. This is 1, this is 2, this is 3, this is 4. So this is called 1,4 product. Right? So now in this case, we have two possibilities. Now anyone can tell me which one is more stable? 1,2 or 1,4? 1,2 is more stable or 1,4 is more stable? So very simple, 1,4 is more stable because this double bond is more substituted, right? This double bond is more substituted than this double bond. So 1,4 product, this is more stable. So stability of 1,4 product is more than 1,2 product. So we can say that this is kinetically controlled, this is thermodynamically controlled, and this is kinetically controlled product. So here, if we examine this reaction at low temperature like -80 degrees Celsius, so this product, 1,2 product, we are getting approximately 81%, and this we are getting 19%, right? But if we take this reaction at 40 degrees Celsius, so the situation is just reversed. So we are getting here 20%, and here we are getting 80%. So what we can say that this is kinetically controlled product. 1,2 product is kinetically controlled and 1,4 product is thermodynamically controlled in this case, right? At minus 80 degrees Celsius, the reaction is irreversible. So the product which is formed, already we have discussed this, what are kinetically controlled product, what are thermodynamically controlled product, what is the requirement for that. In thermodynamically controlled product, the overall energy of the molecule is less, but in kinetically controlled product, the activation energy for the formation of that product is less, right? So at low temperature, the reactions, this reaction is irreversible. I mean, formation of this product is irreversible. So no sufficient energy is there that can rearrange this 1,2 into 1,4. So we are getting 1,4 less in less quantity at lower temperature, and 1,2 is in as a major product, right? If you want to plot the graph and show the energy profile of this reaction, so you can very easily demonstrate this. See, and suppose that this is this is 1,4 product. So in the first step, this this path is almost same for both. From here, the situation differs. So this is for 1,2 product, right? So this along this region, in this region, there is no much difference between 1,2 and one path of 1,2 and 1,4 product. See, from here the difference created. This is the activation energy for EA1. This is for kinetically controlled, and this is the activation energy for thermodynamically controlled, EA2. So activation energy for this is EA1, and for this is EA2. So EA2 is more than EA1, right? And here, what is the intermediate? So if we see the mechanism, so we can start from here that this initially H plus will attack, and this H plus will attack either side of this carbon or this carbon, carbon number 1 or carbon number 4, because this is equivalent. Carbon number 1 and 4 are equivalent. Now, why not this H plus will attack on carbon number 2? Because if H plus will attack at carbon number 2, you will get primary carbocation. And if H plus will attack at carbon number 1, then you will get secondary carbocation along with the allylic, right? So secondary allylic we are getting. So obviously the H plus will attack on carbon number 1 or carbon number 4, and both can, no difference between 1 and 4. So if we see, the hydrogen will attack here, positive charge will come here, and double bond is here, right? So this will be, delocalization will take place, and positive charge will come here, right? So what we can represent here, at this state, positive charge, you can show this positive charge anywhere, transition state of positive charge, right? Like this. right? Okay, so this is the intermediate transition state. This is the redetermining step, first step, right? So this is the energy profile of this reaction. This is reaction coordinate or progress of the reaction, and this is the energy. So you can see this is this product has lower energy, so definitely this is thermodynamically controlled product, and this is kinetically controlled. So आप लोगों को पता है अभी हम लोग 10 मिनट का समय और बचा हुआ है हम लोगों के पास, ठीक है? तो एक्चुअली कल हम लोगों ने हेड सर ने मीटिंग लिया था सबका, और ये बताया था कि इसी पर हम लोग क्लास करें। ये थोड़ा सा ज्यादा इंटरैक्टिव इंटरफेस है इसका, हम लोगों का जो जूम का है, और मीट पे क्या होता है ना, शेयरिंग एंड इन सब में थोड़ी सी प्रॉब्लम आती है। अभी तक किसी को कोई दिक्कत तो नहीं हो रही है वॉइस में और या स्क्रीन में? हर चीज विजिबल है सबको क्लियरली? ओके, तो ठीक है, आज ये हम लोग का पहला एक्सपेरिमेंट था। तो हम लोग आगे फ्यूचर में भी इस तरीके से करेंगे। आप लोगों को प्रॉब्लम की प्रैक्टिस करनी होगी तब भी मैं करा दूंगा, भले क्लास हो या ना हो, ठीक है? तो so now this is addition over conjugated system, electrophilic addition, 1,4 versus 1,2 product, kinetically versus thermodynamically controlled product, right? So at room temperature or above than room temperature, what is happening? This 1,2 product that will I mean this transition state that will rearrange very easily, and sufficient energy is there, so that will prefer to form this thermodynamically controlled product, right? Now I am giving you one case, one example of this. Apply your suppose that this type of system is given. Now one equivalent of HBr is given. Now the problem is that I'm not taking this as a IUPAC system numbering. I'm just taking a number, giving number to these carbons. Like this is 1, this is 2, this is 3, this is 4. Now tell me that initial attack of H plus will take place at carbon number 1 or at carbon number 4. This is true that this will start either from 1 or from 4. This will not start from 2 or 3. That is true. You don't expect that H plus will attack here or H plus will attack here. That is always true. Now tell me this H plus starts attacking from carbon number 4 or 4 number or at 1 number. होगा H plus, ठीक है? रीजन बीइंग कार्बन नंबर 4 पे आप अटैक, अगर आपको आई मीन क्लियर नहीं है तो आप क्या करो, एक बार कार्बन नंबर 4 पे अटैक करा लो और सारे इंटरमीडिएट्स बना करके उनकी स्टेबिलिटी को कंपेयर कर लो, और एक बार 1 पे अटैक करा के कर लो, क्लियर हो जाएगा। बहुत ज्यादा इसमें याद करने की भी बात नहीं है। तो अगर आप 4 पे अटैक कराते हो तो क्या मिलेगा कार्बोकैटायन आपको? कार्बोकैटायन यहां आएगा, ठीक है? तो ये क्या बन गया? सेकेंडरी कार्बोकैटायन, और एलाइलिक भी है इधर से, ये अपना बनाएगा जो भी है रेजोनेटिंग स्ट्रक्चर। ये जब हमने 4 पर अटैक कराया, अब हम लोग 1 पर अटैक करा रहे हैं। जब 1 पर हाइड्रोजन का अटैक करा रहे हैं हम लोग, तो पॉजिटिव चार्ज यहाँ पे आ रहा है, और ये है, ये कैसा कार्बोकैटायन है? सेकेंडरी कार्बोकैटायन है। अब इसका जो है, अगर हम लोग सेकेंडरी एलाइलिक है, अब अगर हम लोग इसका रेजोनेटिंग फॉर्म बनाए तो ये कार्बोकैटायन यहां पर जा रहा है। ये कैसा कार्बोकैटायन है? सेकेंडरी प्लस एलाइलिक, सेकेंडरी प्लस एलाइलिक, ठीक है। तो ये सेकेंडरी एलाइलिक, यहां पर सेकेंडरी एलाइलिक, इसका जब आप बनाएंगे तो क्या बनेगा, प्राइमरी कार्बोकैटायन, राइट, प्राइमरी एलाइलिक। तो अगर हम लोग कंपेयर करें तो इन दोनों में कौन सा सिस्टम ज्यादा स्टेबल मिल रहा है, ये 4 का सिस्टम ज्यादा स्टेबल मिल रहा है या 1 का सिस्टम ज्यादा स्टेबल, 1 का सिस्टम ज्यादा स्टेबल मिल रहा है, तो रिएक्शन इससे प्रोसीड होगा, ठीक है। तो बताइए क्या प्रोडक्ट बनेगा फाइनली इसमें, 1,4 प्रोडक्ट, मेजर प्रोडक्ट। अगर हमने टेम्परेचर नहीं दिया है किसी भी क्वेश्चन में, अगर टेम्परेचर नहीं दिया गया है तो आप अप्रोक्सीमेट रूम टेम्परेचर लेकर के चलेंगे और आपको प्रोडक्ट क्या मिलेगा, CH3H दिया, ये 1,4 प्रोडक्ट। रेजियो सेलेक्टिविटी आ गई, तो रेजियो सेलेक्टिविटी आ गई तो आपको क्या करना होगा, ये एनालाइज करना होगा कि कौन सा कार्बोकैटायन ज्यादा स्टेबल हमें मिल रहा है। तो जनरली अगर आप एक जनरल रूल देखना चाहते हैं, आप ये देख लीजिएगा, डबल बॉन्ड अगर मान लेते हैं सब्स्टिट्यूटेड है तो लेस सब्स्टिट्यूटेड डबल बॉन्ड की तरफ से अटैक हमेशा शुरू होगा, ठीक है, इन केस ऑफ कॉन्जुगेटेड सिस्टम। क्लियर टू एवरीवन? ओके, नाउ अगर आपको ऐसा सिस्टम दे दिया है तो क्या ये कॉन्जुगेटेड सिस्टम का एग्जांपल है या नहीं है, 1 इक्विवेलेंट ऑफ HBr इस पे ऐड करना हो, आप खुद से बनाइए। Now, in place of HBr, if we take here bromine, right, then also you get the similar product, similar 1 to 1,4. So any electrophile you can take here, you will get the similar kind of product, right? So now you can do yourself, the in place of HBr, you can take bromine, bromine water or bromine in CCl4, similar kind of product you will get.